Well, remember, aluminum is in group 3, it'll be +3. Bromine is in group 7, it'll be -1. You need 3 -1s to neutralize a +3. Electrolytes. Who's ever seen the movie Idiocracy? Where they keep watering the farm field with Gatorade. Anyway, that kills all the plants. Because Gatorade has electrolytes. And electrolytes are anything that, when they dissolve in water, they form ions. And so when you say electrolyte, what you really mean is salt. Gatorade has a little bit of sodium chloride and a little bit of potassium chloride to replenish the sodium and potassium a person loses if they sweat a lot.
We go to chicken and bonbons, the babies. We give electrolytes to them. They're like, it's well, it's considered. It helps them to, like, when they first get there, they're stressed because they're only about 2 days old.
Mm-hmm.
So I put it in their water, and it seems to help them, like, boost their immune systems, and it, like, just helps them.
Probably just hydrates them.
Yeah.
Like Pedialyte, same thing.
Yep.
Using electrolytes to rehydrate them. Like Pedialyte is even better than Gatorade. I mean, because like that stuff is formulated for like a 3-month-old baby who has epic diarrhea. You want to make sure the baby doesn't dehydrate to death. So it's about as good of a rehydration solution as you're going to get.
Yeah, when my sister goes hiking, she always takes some of that. Like, she lives in Colorado.
Yeah, it's smart. I mean, yeah, I do recommend it for those things. It's not just for babies. It is going to be your best rehydration solution. Non-electrolytes are things that when they dissolve into water, they don't form ions. There's no positives or negatives. So like sugar. Sugar dissolves in water, but you get no positive or negative charges. Salt is an electrolyte. If you dissolve salt into water, you get sodium plus and chloride minus. And those positives and negatives can conduct electricity, which is why we call them an electrolyte. So in the movie Idiocracy, they realized that they could just use water instead of Gatorade to farm the fields, and then plants started growing again. It used to be something they would do like way back in ancient times, like they called it salting the earth. But if you wanted to like destroy a place and no one could live there again, they purposely put salt onto the fields, because then you couldn't grow any crops. And if you can't grow any crops, no one can live there because there's no food. And so it was done like as like a punishment and stuff. But that movie just took it to the next level of ridiculousness. But either way, you'll never forget electrolytes now. Here, pure water does not conduct electricity. However, you have to put a big asterisk on that, because tap water does conduct electricity. Well water does conduct electricity. You should never use electric things while you're in a bathtub. That is a terrible, terrible idea. Because even though pure water doesn't conduct electricity, things like tap water and well water have enough dissolved electrolytes that they do conduct electricity. So here, this is like pure lab water. This has been deionized. So if your water is coming straight out of a millipore deionization system, then yes, it will not conduct electricity, because pure water does not conduct electricity. But anywhere else outside of a lab, it will, just because things inevitably get into the water. So lake water, river water, there's tons of stuff dissolved in there. It will absolutely conduct electricity. And so that's one of those cases where, in theory, water doesn't conduct electricity, and in a lab it doesn't, but in most of your normal experiences it will. And so you got to take that into account. If we dissolve sugar in water, yeah?
Does it depend on, like, how big the thing is if you drop it in there, like, you know, all those rich movies where they have those TVs by their tub, and what if that would, like, I mean, if it's still plugged in, obviously it would, but if it's unplugged and it drops in there, nothing will happen. But if they actually would fall in there plugged in, that would be kind of bad, wouldn't it?
You could definitely die from electrocution,
That
yeah.
would suck. Who would do that? Yeah, I'll put a TV right here and it falls.
I mean, with electricity, everything comes down to voltage and amperage.
Yeah.
How many volts is something running at, and how many amps is it running at? So like, think about water. The amount of water coming through your hose, that's like amperage, the amount of electrons flowing through something.
Yeah.
How hot the water is flowing through, that's like voltage. How much energy does each electron have as it's coming?
Right.
And the end result is a combination of those two things.
Mm-hmm.
Anything that plugs into your wall is running off of 120 volts, which is a lot. That can easily like a person. if a person's like on their cell phone and it falls in, no, because the machine's just not using enough electricity.
Right.
It's that type of thing where like, if you put a AA battery in your mouth, nothing would happen. But if you put a 9-volt battery in your tongue, it would zap it. Because now all of a sudden you have enough voltage and amperage that you would absolutely feel that. And then it just gets worse from there.
Those people who put toasters or whatever, like what? Like there's cartoons where they put like toasters or something in the water or whatever it is. Like,
I mean, toasters, I mean, that's not normal in your bathtub, but like hair dryers used to be a worry. Because like that is a normal thing to find in a bathroom.
yeah.
no one makes toast in the bathroom.
Well, there was this one
What if you get hungry when you're taking a bath?
I don't know, I mean, maybe you just gotta take a break and take a snack and get back to the shower or something. I mean, if you literally can't wait until the end of the shower, you just gotta deal with it.
Well, there's like some, I don't know, there's like this one, I don't know, there's some sketched out scary movie I watched, and this chick, she wanted to like kill herself, so she literally sat in the tub, she had a toaster, and electrocuted her.
I mean, well, that's sad, but I mean,
I was like, what kind of scary movie is this? She put a toaster in the, okay. She could put anything else in her bathroom, but she wanted a toaster. Okay. I was like, I started laughing. I'm like, this is not something to laugh about. It's a toaster.
And you're still laughing about it.
I know. I don't know. Yeah. That's why I said a toaster. Don't think I'm crazy, because I'm not. But I seriously saw somebody, or not saw, but
120 volts is actually one of the more dangerous electricities because it'll grab you and hold on to you, and you can't let go of it. It won't let you. Like I remember that from electricity classes in high school. I absolutely hated 120 volt circuits.
Wow.
Like a 400 volt circuit will actually blow your hand back. And so like it's painful if you mess up on a 400 volt circuit, but I thought 120 was worse because it would grab you and hold on to you.
you've had to go through this?
I took some classes in high school on
How did you
electricity.
do this?
Yeah.
Did it like, I don't know.
I can wire a 3-way switch. I know some basic electronics. Like I could wire a garage. I couldn't do like a house or anything. I don't know. I mean, how else do you figure out what you're going to do in life? You try stuff and see what you like and what you don't like and what you're good at and what you're not good at, and you come to some sort of equilibrium there. Like everyone has skills. The thing is you have to figure out what you're good at.
Yeah.
And then that's part of school. It's one of the reasons they give you so many electives, because they want you to try things out and figure out, what you want to do, what you want to be.
So I want to try that barbed wire where you touch it, you hold on to somebody else, and it goes through you, and somebody else, I want to try that.
Wait, what?
Like you hold on to like electric fence, you have friends.
Don't do that.
Why?
Because if electricity is flowing through people, it's going across their heart.
Yeah.
Like your heart is your weak spot with electricity.
Yeah.
If someone dies from electricity, it was a heart attack because of electricity. So you never want it going across someone's chest, ever.
Oh.
So don't touch electric fences.
But yeah, they would say, oh,
I think that'd be really painful. Like those things are pretty high voltage.
No, it's
Like
like
ours isn't that painful, but we don't have it like super high. We have it so it pulses, so if someone does touch it, they can let go.
Okay, well that's good.
Yeah.
Is that for cows or
Horses.
horses? Gotcha. All right. So we have electrolytes and non-electrolytes. Electrolytes, again, when they dissolve in water, they produce ions. Ions have a charge, and they're dissolved, so they're free to move. Whenever you have moving charge, you can have electricity. That's why metal conducts electricity. The electrons are free to move through it. They have a negative charge, you have moving charge. Here you have ions, which have a charge, and they're free to move. Non-electrolytes dissolve but do not have any charge. They do not conduct any electricity. Which compound will not dissociate in water? Methanol. This one will form into sodium plus and hydroxide. HCl dissolves and get H plus and Cl minus. KBr. All group 1 salts were soluble. We learned that last chapter. So this will be soluble in water and dissolve into potassium plus and bromide minus. But methanol is organic and does not dissociate into ions. Salts dissociate into the respective cations and anions when dissolved in water. And so here we see sodium chloride dissolving. It goes from solid to aqueous. Aqueous means something is fully dissolved. and it has a shell of hydration. There's a shell of waters around it that stick to it and move with it wherever it goes. It belongs to that ion. And biologically, that's important. That's how your body tells potassium and sodium apart from each other, is the thickness of that shell of hydration. And here we see the negative part of water will associate with the sodium plus. The positive part of water will associate with the Cl minus, and it'll form a shell around it. Now this moves as one unit in any aqueous system. And because all living things are water-based, all living things with their ions are based on this system. So when you dissolve salt in water, that's what's happening. The positives are grabbing the negative chlorines and pulling it out of the salt formation. And the negatives of water are grabbing the positives in sodium and pulling it out of the salt formation. So, acids ionize in water, producing H3O plus and a counterion. This is just a simple way to write it. What they mean is that the water is grabbing this H plus. In reality, it's about 8 or 9 molecules of water hold a single proton, but I think it's kind of complicated to write. So H3O plus is just symbolizing the fact that water is holding your extra H plus. With any acid-base system, your solvent always determines the most acidic you can get. And so if water is your solvent, H3O plus is the strongest acid that's going to be there, and OH minus is the strongest base that's going to be there. Bases also ionize in water. And so here is a Bronsted-Lowry base. Ammonia accepts a proton, leaving a hydroxide where there was water and an NH4 plus ion. Strong electrolytes and weak electrolytes. Some compounds, when they dissolve in water, 100% of them dissociate into ions, like salt or HCl. When every single molecule breaks apart into ions. And some don't, like vinegar, acetic acid. 95% of acetic acid stay together. Only 5% of them break apart into ions, and that's a weak electrolyte. In a strong electrolyte, every single molecule breaks apart into its ions. In a weak electrolyte, only a small percentage of the molecules break apart into their ions. So the strong electrolytes are going to be your soluble salts, your strong acids, sulfuric, nitric acid, hydrochloric, hydrobromic, perchloric, and we're missing hydroiodic. So you have 6 strong acids. And then your group 1 hydroxides, and then your soluble group 2 hydroxides. So basically everything below magnesium. Magnesium hydroxide doesn't really break out much, but calcium and down completely dissociates. So you have your soluble salts, your 6 strong acids, which is HCl, HBr, HI, and sulfuric acid, nitric acid, and perchloric acid are your 6 strong mineral acids. In organic chemistry, you'll see lots more strong acids like triflic acid and magic acid, all sorts of acids. But in this class, we have 6 strong mineral acids. And you have your group 1 hydroxides and the group 2 hydroxides besides magnesium. Any questions on that? The weak electrolytes are your weak acids and your weak bases. With the salts, generally they completely dissolve or none of it dissolves. You can make a case for slightly soluble being a weak electrolyte because a little bit of it dissolves, but that almost never comes up. With the weak ionizations, we use a double arrow, signifying that both processes are happening simultaneously. Fluoride, that's an interesting case in organic chemistry, because in water it's a weak nucleophile. It has a hard time attacking things because water grabs onto it super tightly. However, in an organic solvent, it's a really strong nucleophile because it gets rid of all these water molecules that are holding on to it. It's free to attack things, and it's really powerful then.